So in this video we are going to see about the allotropes of carbon and their properties. So mainly we are only studying about three allotropes of carbon in this chapter. They are diamond, graphite and fullerenes. So before that, allotropes means what? That we need to know. So allotropes is nothing but different forms of a same element. Okay, so that means carbon in earth can exist in different forms. So one of the form is diamond, one is graphite, one is fullerene. Okay, these are also called crystalline allotropes because crystalline allotropes have a definite pattern in their structure. That means if we zoom in the structure of this diamond, graphite or fullerene, we will be able to see some pattern. Okay, for example, if we zoom in some of the structures, not this structure, okay, I'm not talking about diamond and or graphite, but generally I am saying if I zoom in some of the structures, I will see some cubic patterns in their lattice, we will say. So whenever we are seeing such patterns, that is when we call them, they are having a crystalline nature. Okay, that is, we will also call them crystals. So please understand, whenever you hear the word crystal or crystalline, understand that there is a definite pattern in their structure or repeating unit. Okay, repeating unit. But whenever we say amorphous means they are not having definite pattern. Also, they are not having any repeating unit in their structure, or we will also say the lattice means the structure we are meaning. Okay, so just understand, carbon is having different allotropes. The main allotropes that we are studying are diamond, graphite and fullerene, but carbon can also have amorphous allotropes like coal, charcoal, etc. Now first let us look at the allotrope diamond. Okay, diamond. So how is their structure? So I will draw the structure of diamond. Okay, so then you will understand the how the structure of diamond is. So it is an interesting structure. You see these dots, every dots that I am drawing refer to one carbon. Okay, so this carbon is bonded to another carbon in diamond. So now this is the second carbon, so this is the third carbon, it's attached to one more carbon here. Now the next carbon comes, so it will be attached like this. So this is also carbons. Okay, so I'm just, for your clarification, I am drawing it like this. So one more it will be here, then one here. Okay, now the third one will come, so it will be like this. So I'll keep this diagram little down. Now I will draw one more. Okay, so for your understanding I will change the color. So this carbon is bonded to this carbon. See, so this is the three-dimensional structure of these diamonds. Okay, so you just need to understand it is having a three-dimensional structure. That means it is extending to all the directions. So all these are carbons. Okay, all these dots, all these balls, all are carbons, all are same carbons. Just for your understanding, I have made it in different colors. So diamond is having a three-dimensional network structure. Three-dimensional network structure. That means it is we need to draw this diamond in a 3D way. That means we need to take x-axis, y-axis and z-axis to draw the structure. Okay, that is why it is called three-dimensional. And network means these are all interconnected. That is why this is a three-dimensional network structure, and this is very strong. Okay, very strong. This structure is, so that is why it is diamond is having very high melting point and boiling point. Okay, MP means melting, P means point. Okay, similarly boiling point as well. Also, the refractive index of diamond is very high. Refractive index. So what is refractive index? Refractive index means how light deviates when it passes from one medium to the another. Okay, so the specialty about diamond is that the diamond is having very high refractive index. Okay, that is why whenever a light enters this diamond crystal, it will undergo total internal reflection inside that diamond. Okay, total internal reflection. Total internal reflection means if the medium is having very high refractive index, the incident ray and the refracted ray both will be in the same medium. Okay, that means the refracted ray will come back to the same medium. So in that way you need to understand, whenever a light beam enters a diamond, it will not come out of the diamond, it will undergo total internal reflection inside the diamond. Okay, that is why we are seeing diamond as very bright, very shiny. So we can also write diamond is very shiny. Diamond is very shiny. Okay, and diamond will not conduct electricity, but it is having high thermal conductivity. Okay, thermal means heat, so it will conduct heat but not electricity. Okay, so all these point you have to keep in your mind about diamond. Now let us look at the structure of graphite. So here I will draw the structure of graphite. Okay, so we can easily draw the structure of graphite. So I am drawing here. So C, I will take C. Okay, carbon itself. So carbon is arranged in a hexagonal sheet-like manner in graphite. Okay, so like this. So this is a simplest way of drawing it. So all these are carbons. Okay, so this is like a one sheet of carbon. So this is like a sheet, it will extend to all direction. Okay, so it will just extend it like this, it will become bigger and bigger. So the next thing is, a number of layers will come, okay, above and below it. Okay, so just like this. Okay, so this is another graphite layer. And the important thing is that there is small interaction between these different layers. Okay, so I will just draw these lines to show the interaction. So all these lines represents a small force of interaction between the different layers. So this force of interaction is also called van der Waals force of attraction. Okay, van der Waals force of attraction. So in graphite it is like one layer on top of the other. So these different layers can slide over each other. Okay, for example, imagine two wooden blocks, one yellow color, one green color. Okay, imagine these two are wooden blocks. So if I push from this side, this block will move, right? So it can even reach like this. Okay, so it will move. Okay, similarly these different layers of graphite will be able to slide one over the other. That is why graphite is slippery. Okay, graphite is slippery Okay, so this property is used in our pencil. So when we slide the graphite in our pencil, these different graphite layers are just getting slided over one over the other, and these layers are getting adhered to the paper. Okay, so that is why we are able to write with the pencils. Actually, pencil lead is having this graphite. So graphite is slippery, graphite is also smooth. And the most important point about this graphite is, see, look at here, each carbon is bonded to only 3 carbons. Okay, so each carbon is bonded to only 3 carbons. So but we know that one carbon is able to form 4 bonds. Okay, so now 3 electron is shared. Actually 3 electron is only shared by one carbon. So here I will represent one electron of this carbon, another electron of this carbon. Okay, so 3 electrons are shared in bonds, and the last electron, okay, so that last electron is delocalized, so it will be present in the lattice like this. So all these carbons will have one delocalized electrons present in their structure. So these electrons are responsible for the conductivity in graphite. Okay, so we can also write graphite conducts electricity. Conducts electricity because of the free electrons. So these are the free electrons present in them. Okay, and graphite is also having high melting point. It will conduct heat, etc. And the appearance of graphite, it's like a dull shiny. It's shiny to an extent, but not shiny like what, like metals. Okay, that is also a point we need to keep in mind. So you can also write graphite is having hexagonal sheet like structure. That is also one point you can write about graphite. Okay, if you have any doubt in this graphite or diamond, you can mention that in the comments. Okay, so I will reply to your questions. So graphite is over. The next thing that we are studying is fullerenes. Okay, so fullerenes. So we are only learning little about fullerenes. Okay, the structure of fullerenes, it is little complicated to draw. Okay, so we don't have to draw it, but we can learn some of the properties of fullerenes. Okay, so an easy way to draw it is like this. So first we need to draw a pentagon, then from there draw hexagons, okay, then what we can do is, okay, so it just, okay, so this is a similar structure of these fullerenes. So it will be something like a football. Okay, fullerenes. So we don't want to worry about the structure so much. Just understand that fullerenes have a spherical ball-like structure. Okay, and the important point is here all the carbon atoms are arranged in a spherical manner. Okay, that is what we can write. So there are different fullerenes like C60, C70, C80. Okay, so like that there are different fullerenes. Okay, that means C60 means there will be 60 carbons in that structure. C70 means there will be 70 carbons in that structure, like that. Okay, so that is the point here. And fullerenes also conduct electricity. Okay, that is also one more point. Fullerenes also conduct electricity because you can look at the structure. Here also one carbon is bonded to only 3 other carbons. Okay, so one electron is delocalized. Like that, and all these carbons will contribute different electrons. In that way, it will also conduct what electricity. This C60 Fullerene is also called Buckminsterfullerene. Buckminsterfullerene, because it is the person named Buckminster built a structure. Okay, so he made a geodesic dome. So if you search in Google, you can see. So this C60 Fullerene was similar to that structure. So it was C60 is also called as Buckminsterfullerene. So only this you have to learn in the allotropes of carbon. So if you have any doubt, if you want explanation to any other thing, you can comment below. Okay.